I'm your host, Frank Aragona. Today we wrap up with the interview with visionary mycologist Paul Stamets. I continued the interview by asking Paul about the medicinal value of mushrooms and mushrooms mycelium and some of his research in that area.
So this is a terrible scenario, but it is a scenario that the U.S. government and other governments around the world believe is real and it is significant. And it's far better to think about this now, to come up with preventive remedies, and then trying to treat it after the fact. But treating after the fact is going to literally unravel the fabric of our society. And some of the big concerns that people even have about bird flu now. And if it's not smallpox, it could be bird flu. It could be SARS. Does anybody really think SARS has gone away? No. I mean, SARS was carried by civet cats. Civet cats eat birds. Birds carry bird flu and West Nile virus by mosquitoes. All those viruses are being mixed up. And the potential of a viral epidemic appearing on the near horizon in our lifetime is a very real and poignant threat. All the more reason that we should look for alternative remedies and explore the natural world for compounds that can help prevent these disease vectors. That's one of dozens of examples that I can give you, but it's very salient. And I would encourage any listener to listen to the NPR.org interview, and that is smallpox AGROINNOVATIONS press release vetted by the U.S. Defense Department. And if you punch in my name in Google, Stamets and smallpox, you can see it under a company called yet2.com, and that is a U.S. government-approved press release concerning my research.
So now one of your proposed solutions obviously is conserving our forests in the Northwest. And that kind of leads me to my next question, which is about the tropics. Now, as you've mentioned, you've spent many years isolating cultivars from the woods of the Pacific Northwest, and the biodiversity there pales in comparison to places like the Amazon. What do we know about edible species with tropical origins?
Well, there's not, surprisingly, as many edible mushrooms in the tropics as there are in the temperate regions of the world. The saprophytic fungi are operating at light speed, so to speak, in the tropics because there's not a winter to shut down or slow down the life cycles. But the biodiversity, for instance, or the mycodiversity in Hawaii pales in comparison to the mycodiversity in the Pacific Northwest. We have 4,000 to 6,000 species here in the Northwest, and Hawaii is in the hundreds. So it's hard to, as they say, paint the canvas with one brush. So some areas of the tropics are a lot more mycologically active in terms of the life cycles, but have less biodiversity. There's more edible mushrooms in temperate regions than there are in tropical regions. It's just the luck of the draw, so to speak. There are a lot more edible species in there's a longer tradition of eating edible mushrooms in the northern temperate regions than there are in the southern temperate regions. So there are pockets of knowledge that have evolved in civilizations, and experts and families tell others about the mushrooms that they enjoy, and so the body intellect in those cultures spreads out. Other areas that don't have as much populations, or for whatever reason they didn't discover that these mushrooms exist in their landscape, have a lot fewer or a lot less knowledge. But the fungi are on the march, and as global warming defrosts the temperate zone, then there's going to be an inevitable migration of temperate species into the Arctic regions, and similarly a migration of tropical species into the sub-temperate regions. The biodiversity of all organisms, I think, is part of and especially with fungi, these are essential elements in our biological tool chest. And when we lose these species, we're losing like rivets in an airplane. That can lead to catastrophic failure. How many species will we lose before the entire system goes through a cataclysmic failure? And in doing so, species at the top of the food chain is obviously going to be greatly impacted, because the food chain is a sequence of microorganisms to macroorganisms. and that's being macroorganisms. If we don't have the microbes to help us in our food chains, we'll have nothing to eat. So this is all a very complex subject, but the whole concept of Gaia, and Gaia being one macroorganism composed of individuals, well, that concept mimics you and I today. I am Paul Stamets, speaking with one voice, but I'm a consortium of microbes that are unified together to create this body. And although I'm speaking with one voice, I am representing a constellation of microbes that are unified in symbiosis to speak to you and to your listeners. And so I think the symbiosis is the way of nature. Nature loves partnerships. Partnerships are rewarded, and there are many, many examples. Here's one that I think is very cool. A group of scientists discovered the atine ants in North Africa, cultivate a Lepiota parasol mushroom. This mushroom is very large, is edible in choice. It gets to 2 to 3 feet in diameter. Well, the atine ants cultivate the mycelium in their nest, and the mycelium in their nest preselects a bacterium. And this bacterium produces an antibiotic that's active against Escovopsis. Escovopsis is a fungus that parasitizes ant colonies. And so the ants have learned through natural selection and evolution, and maybe just good luck, and by happenstance, that if they cultivate the mycelium of this mushroom, it produces the bacterium that produces the antibiotic that prevents another fungal infection that's dangerous to them. So the ants now become little mushroom cultivators, moving fragments of mycelium around. And that, I think, is one example that is a model upon which much of nature is based.
Now, speaking of using mushrooms to protect from something that's poisonous or toxic, talk about the use of mycelium in bioremediation, please.
Well, I have a new book, as you know. It's called Mycelium Running, How Mushrooms Can Help Save the World. And this book is on the subtitle could be Mycorestoration. Mycorestoration contains 5 components: mycofiltration, the use of mycelium to filter out bacteria and microbes and silt into downstream environments, using the mycelium as a biological filter. There's mycoremediation, the breaking down of toxic waste, such as petroleum products, using the mycelial enzymes and acids that are very, very good at breaking down recalcitrant pollutants, especially petroleum-based ones. There's mycopesticides or mycoinsecticides, which uses fungi to trick and kill termites and carpenter ants and other quote-unquote pest insects. I don't like that phrase, but that's what's used. And there's mycoforestry, the combination of mycelium to help forest ecosystems, myco-gardening, combination of mycelium to help gardening. And those are the 5 pedestals of mycorestoration. And the mycoremediation is something that I've focused on a lot for many years. And we did some experiments to break down petroleum diesel spills in Bellingham, Washington, with the Department of Transportation. And I worked with Battelle Laboratories for 4 or 5 years, and we introduced oyster mushroom mycelium into a mound of petroleum-contaminated soil. It had 2% of what's called PAHs, polycyclic aromatic hydrocarbons. And the PAHs were reduced from 20,000 parts per million to less than 200 in 8 weeks. And this was an astonishing success. No other treatment using biological systems worked this fast. Our pile started fruiting with oyster mushrooms prolifically, hundreds of mushrooms. And this is all featured in my books, and the mushrooms are perfectly edible and detoxified the substrate. So mycoremediation has really surged in the past few years and has gone through a rebirth in the past 2 to 3 years. And there are several groups now around the world actively using mycoremediation strategies to break down toxic waste in their ecosystem. So I would really encourage people to I'm unabashed about this, because this is the first book that I wrote. I've got 6 books out. This is the first book that I wrote that I was so anxious to get it done. I was so concerned that I'd either have a heart attack, I'd have a car accident, I would die before the book came out. Because the book is more important than the author that wrote it. The book is indeed something that can help humanity, and I think this book will carry on through many lifetimes because it shows people the way of using mycelium to help the ecosystem and ultimately help ourselves.